If you plug thousands of devices into a single massive network, you end up with chaotic traffic and significant IP address waste. To fix this, network engineers use subnetting, dividing that large network into smaller, manageable, and secure subnetworks. Every IPv4 address is split into two distinct parts: the network portion, which functions like a street name, and the host portion, which identifies the specific device on that street. This diagram shows using CIDR notation to define the exact boundary between network and host bits. A /24 is straightforward, but at a /28, calculating binary math is too slow for an exam. You need a faster approach, the magic number. Mastering subnetting isn't about performing grueling binary math. It's about using this decimal shortcut to save time and mental energy. The formula is simple. Take the number 256 and subtract the interesting octet of your subnet mask. The result is your network's block size. Let's apply this to a specific problem. We need to find the full subnet details for the IP address 10.1.1.55 with a /28 notation. First, convert the /28 to decimal. It maps directly to 255.255.255.240. Subtracting 240 from 256 gives a block size of 16. Count up from 0 by 16. 0, 16, 32, 48, 64. Our target, .55, falls exactly between 48 and 64. The lower boundary of this block, .48, is the official network ID. By adding 1 to that network ID, we get the first usable IP, .49. The broadcast address is the next network boundary, 64, minus 1, resulting in .63. Subtracting 1 from the broadcast address gives us our last usable IP, .62. While the total number of IPs equals the block size of 16, the usable hosts are always 2 less, because the network ID and broadcast address cannot be assigned to devices. That leaves us with 14 usable addresses. This subtraction method identifies every parameter of a subnet in seconds, entirely bypassing the need to write out 32 bits of binary. Now, try it yourself. Pause the video and use the magic number to find the network ID and broadcast address for 192.168.4.88 with a /26. Here's the solution. A /26 translates to a mask value of 192. Subtracting 192 from 256 gives us a magic number of 64. Counting by increments of 64 gives us 0, 64, and 128. Because 88 falls in the 64 block, the network ID is .64 and the broadcast is .127. In practice, networks aren't always divided into equal pieces. Engineers use variable length subnet masking, or VLSM, to prevent IP exhaustion. As this chart illustrates, VLSM allows a large /24 block to be progressively sliced into smaller, unequal subnets based on the host requirements of specific departments. Mastering VLSM allows you to move beyond theoretical whiteboard sketches and architect optimized real-world network environments. Because subnetting is a core component of the CCNA, your first action in the exam room should be mapping out a reference cheat sheet during the initial 10-minute tutorial. This chart shows how a cheat sheet works in a professional context, mapping CIDR notations directly to address ranges and host counts for different office branches. Always remember that network ranges step up in exact increments of your magic number. This serves as a built-in error check for your calculations. Subnetting is a base-level competency required for network design. Screenshot this final matrix, practice the shortcut, and you'll be able to solve these problems under the pressure of the exam.